So the general idea for today is we're thinking about when functions are increasing, when they're decreasing, and when they exhibit local maxima and local minima. So last class we were looking at when functions have absolute maximums and absolute minimums, right? Those were the things that were the biggest over the entire range. So for example, if we had a function like this, last class we were only concerned about the absolute maximums, but today we're interested in all relative extrema. So we're interested in this, we're interested in stuff like this. If we maybe had another one, we'd also be interested in local minimums like that. Okay, and so we need to figure out how we can differentiate between them and how we can determine where they are. So let's start with increasing and decreasing functions. That's pretty straightforward, right? Suppose we had maybe like a cubic function, such as on the classwork, question 1. Maybe it looks like this. So we would say that this function is decreasing in this range, and then it's increasing in this range, and then it's decreasing in this range. Okay, very straightforward. And the way we determine whether it's increasing or decreasing is just by using the derivative, right? So when it's decreasing, that means that the derivative is negative. So we would have f of x less than 0. And then when it's increasing, the derivative is greater than 0. And then when it's decreasing, the derivative is once again less than 0. Yes, Daniel.
So when it's like on the one on the left in the red where you said 0 is greater, what if it's decreasing but it's not below 0 yet? Is it still greater than 0? Is that what you're talking about when you put the derivative for that?
Like here?
Yeah,
Yeah, decreasing doesn't mean negative, right? It means that the derivative is negative.
So you're saying
the slope is going down, right?
But it's slowing
Yeah. Okay, so I'll let you guys try number 1. On number 1, I forgot to write actually the actual function itself. It's supposed to be f of x equals x cubed over 4 minus 3x. Okay? So first, estimate using the graph what are the open intervals on which the function is increasing or decreasing. By open intervals, I mean intervals that have round brackets, right? Because, the thing is, when we're at the exact point at which it has a maximum or minimum, it's not decreasing or increasing, right? It has a 0 slope. And so it's only an open interval on which it's increasing, meaning that it's not increasing at that actual point, but all the way up to that point. All right, so you can look at the graph, see where the open intervals are, and then what I want you to do is take the derivative of the actual function itself and think about where that derivative is negative and where it's positive, and then confirm that your intervals are correct. Make sense? Yeah, classwork. Classwork 3-3.
So do you take the derivative first?
Yep, I would take or you could maybe first look at the graph and think about where it's increasing. So as I look at it, it looks like it's increasing when we have x going from negative infinity all the way to negative 2, right? Because it's increasing at the beginning of the graph all the way to the left. And then I'm going to write a round bracket on the negative 2. Yeah. Okay, I have a round bracket, not a square bracket, because it's not actually increasing at negative 2, because it has a maximum there. The slope is 0 at the maximum of negative 2.
Is it increasing the blue?
We're doing a different graph now. It's number 1 on the classwork.
So this one, it's the negative 2.
It's increasing from negative infinity to negative 2.
Where is that?
And that means x is less than negative 2. And then it starts to decrease starting from negative 2, right? All the way up to positive 2. What way? Points? Those are intervals. Interval notation, right? remember?
Sorry, I'm so confused. Increasing is infinity to -2. Because are you talking about this? This -2?
Yes. When x is less than -2, the graph is increasing, right? It's going upwards.
Yeah, but then it goes back down. So where's the
Right, it's only increasing on this interval between -infinity to -2. When x is greater than -infinity and less than -2, the graph is increasing.
So as it's going to -infinity.
All right, any questions?
A lot.
Okay.
So negative infinity is like this, right? It's going down. Is that what you're talking about?
The x values, right? The x values, when they're within this interval of -infinity to -2, the graph is increasing.
And then it stops at -2.
It stops increasing at -2, and it begins to decrease when x is between -2 and 2.
So it's increasing. Then why would it happen?
So it's decreasing, going all the way here,
She said increasing.
or increasing all the way here until it hits -2, which is right here, and then.
Okay, let's go on to how we can determine these intervals using the derivative, not just looking with our eyes. All right, so we're going to find the derivative of f of x. The derivative is going to be 3x squared over 4 minus 3. All right, we just used power rule, so the derivative of x cubed is 3x squared, which means that the derivative is 3x squared over 4 minus 3. And then we're going to think about where this derivative is increasing. So in other words, when is the derivative greater than 0, which means that the function is increasing? So we're going to ask ourselves, when is it increasing? That's when f prime of x is greater than 0. So in other words, we're looking for which intervals of x cause f prime of x to be greater than 0. So we're going to try and solve this inequality, right? And if we solve this inequality, we're going to have 3/4 x squared greater than 3. So x squared is greater than 4. Make sense?
Why couldn't you do it's greater than 0 or less than 0? Why'd you choose greater?
Because when a function is increasing, its derivative is positive. It's greater than 0.
But we also have a decreasing variable.
I'm looking at increasing first.
Oh, we're doing both.
So I'm first trying to find the interval on which the function is increasing. And so I have to solve this inequality, x squared is greater than 4. And if you solve this inequality, x squared is greater than 4, you would find that this is only true when x is less than -2 or x is greater than +2. Okay? Right? Only x values less than -2 or greater than 2 are going to give you a square that's greater than 4. And so that's how we get the intervals -infinity, -2, and 2, infinity. So that's where the function's increasing.
Oh, that makes sense.
All right? And then let's look at where it's decreasing. That's going to be wherever the derivative is less than 0, which means that x squared has to be less than 4 when it's decreasing. And so that only happens when x is between -2 and +2. So we're going to have the interval -2 to +2. All right, so you need to be able to solve these inequalities. They're pretty straightforward, except it's very important not to miss the negative solutions, right? So not missing the -2, and then it should be okay. Any questions?
Last third.
Okay. I'll show you guys another example, and then you guys can do question 2. All right. Let's say we had a function. How should I make this similar to this question? Let's say we had x squared. No, let's not do x squared. Let's just do 2x plus 1 over x. Okay? Just kidding, minus 1 over x. 2x minus 1 over x. And we're going to ask ourselves, which open intervals is this function increasing or decreasing? So we don't have a graph, right? And so we need to do this using calculus or algebra. So we're going to take the derivative, and we know that wherever the derivative is positive, this function is increasing, and wherever the derivative is negative, it's decreasing. So we'll take the derivative, and that's 2 plus 1 over x squared. Because the derivative of 1 over x is negative 1 over x squared. And so that becomes a positive 1 over x squared. All right. So it's going to be increasing wherever this derivative is greater than 0. And so we're trying to solve this inequality now. 2 plus 1 over x squared greater than 0. All right, notice how we have a greater and not a greater than or equal to, because it has to be positive and not just non-negative. All right, and so now we're trying to solve for those values where 1 over x squared is greater than negative 2, right? If we take the reciprocal, sorry, give me 1 second. We are not allowed to take the reciprocal of an inequality, right? That's an important fact. And so let's multiply both sides by x squared. So we'll multiply the left side by x squared, multiply the right side by x squared. And so we have 1 is greater than negative 2x squared. Any questions? So manipulating inequalities can be very challenging, right? Because inequalities are not like equations at all. Inequalities, we can't multiply by negative numbers. Or whenever we multiply by a negative number, you have to flip the sign, right? You guys remember that from algebra? Right? Huh? Yeah, whenever you multiply or divide by a negative number, you have to flip the sign. And also, when you take a reciprocal, you also have to flip the sign. Okay, so you have to be very careful. Inequalities are strange, aren't they? So remember that. But here, I'm multiplying by x squared, right? And x squared is always positive, so I have no troubles there. Okay, and so I'm going to now multiply both sides by negative half to get rid of that negative 2. And now I have to be careful and flip the sign, right? So I have negative half is less than x squared. You guys see why that's very important to flip the sign? Otherwise, I would not get this correct. Any questions about that? Okay, well, x squared is always a positive number, right? Because any square is always positive or non-negative. And so that tells me that this function is always increasing. So it's increasing on the range of all real numbers. All right, any questions? It's a little tricky. Yes? Sure, yeah. That's because this inequality is always true no matter what x is. Okay, because x squared is always a positive number, and it's always going to be greater than negative half, which is negative. Mm-hmm. Yeah, Carter?
So why do you multiply by negative 1 half?
To get rid of this negative 2.
Oh, okay. And then you did the same for the x squared. You
Mm-hmm.
multiplied it.
Yeah. So inequalities, you always need to be careful to think about what you're multiplying by, a negative number or a positive number. And if it's negative, you have to flip the sign. Flip the inequality sign.
But where did the 1 half come from?
I tried to cancel out the negative 2 here. Carter?
So you multiplied the x squared. You didn't flip the sign, but then you put the sign on negative 1.
That's because x squared is always a positive number. And when I multiply by a positive number, I don't flip the sign. Okay, so if I were to graph this function, I'll show you what the graph looks like. The graph looks like this. Okay, and as you can see, it's always increasing, right? Any questions? You guys can do number 2 now. It's very similar, but a little more tricky. Yeah. Sorry about that. It's supposed to say positive. Yeah.
Question. Even if it's not
Mhm.
right there, when you take the derivative of the fraction, how do you get there? So can you do that?
Yeah. This is 2x minus x to the negative 1. And then I do power rule on both of them. So this becomes a 2. This becomes negative x to the negative 2. And so I have 2 minus negative x to the power of negative 2.
So then you move the negative in front. So it'd be plus x squared. And then you go 1 over x squared plus 1 over x squared, right?
Sure? Yeah, I think so.
How you do it?
I don't really understand what you said, but I think
1
so.
over x squared, right? Is
Yeah.
that what that would be?
Yeah, this is 1 over x squared. Let me know if you guys have any questions.
I'll be in the Hamptons. You can come back. Stay for some. Then I go to bed. What is 2? When you take the derivative of the 9 over x, does it become, it becomes 1, and then it's 9 times x, the negative 1?
Yep. Okay, guys, remember that the classwork credit is not guaranteed. It's dependent on your work. Huh? Well, you didn't take the derivative.
I know I am, but I'm just saying is that what it becomes?
Well, it shouldn't be a 1 then, right?
At the front? Well, I took the derivative of the left one. So
Then you should be consistent and take it of the right one as well. You either take it of both or a 9. It's clearer that way. Yeah, Brock. Huh? That means that this inequality is true for all real numbers, right? Because x squared is always positive. Huh? X squared is always greater than negative half. Yeah, it's telling me, this interval is telling me that x is always greater, x squared is always greater than negative half, no matter what it is.
So it's,
That just means all real numbers, right? When we have an interval between negative infinity to infinity.
because when you put it up top,
Yeah.
1 minus, there comes this, then you move this down here. So it becomes, right.
All right, so in this question on the classwork, you also have to check for decreasing, because it's sometimes decreasing. So first take the derivative, and then check where it's positive and where it's negative.
And then, why is it increasing versus decreasing?
Why is it increasing?
Like, how do I find out if it's decreasing or decreasing?
It's increasing when the derivative is positive.
So you do,
Well, it's negative, so it's
you
decreasing.
do f
not
prime
negative.
of x.
Well, there's a, it's negative here.
Well, 1 is positive.
Oh,
So
okay.
you plug in the derivative equation, which is 1 minus 9 over x squared. greater than 0 and less than 0.
Check both cases and solve for x.
This is so dumb. Can I just do this? Can you just multiply this? Can you just multiply this out first? Then you get 1 minus.
So you minus 1, and then you have to divide by -1, so you flip this on. And then you multiply times x squared, so you get 9.
Oh, shit, wait, I was
So that would be 3.
Just like this?
Less than x. So x is greater than 3 and x is less than -3. You can't divide by x greater than you have to divide by x. So should I?
Yep.
X is greater than 3 and x is less than -3 for increasing.
Yep.
So it would be similar as the first one, but instead of the 2, it's basically just like s of 3.
Yep.
So it would be negative infinity, comma, negative 3, and 3, comma, infinity.
That increase.
Of what to do once I get to this point, because also these are the same thing.
Well,
Just
1 is
the
greater than,
sign.
yeah.
So, I
So
don't know what to do.
x squared is less than 9 whenever it's between -3 and 3.
So,
Right. You can first think about when it's equal, right? And then you know that it has to be less than somewhere in between those 2 points.
so
Right, just think like when x is 0, when it's -1, when it's -2, it's less than 9, right?
yeah. I'm sorry, I'm having a really hard time understanding stuff.
It's okay. Yeah.
Check number 2.
So it would be negative 3, comma 3.
I see these intervals, they're good, but which ones are increasing, which ones are decreasing?
Oh, do I just have to label?
Yeah.
Okay. Is the answer like? Oh.
I don't know, man. Increasing would be negative 3.
All right. So your answers should be, it's increasing when x is negative infinity to -3, and also 3 to infinity. And it'll be decreasing when x is between -3 and 3. Okay, that should be your answers.
I got it, Mr. Nice.
Good.
Proud of me?
Sure. Okay, I'll show you guys what the graph looks like, just so you guys can see what's going on.
So now you determine that.
The graph looks like this.
Did you take the square root? Then this is plus or minus 3. Less than 3.
Okay, that's the graph, what the graph looks like, and so we can confirm then that when x is less than -3 and also greater than 3, clearly the graph is increasing. And then when it's between that, it's always decreasing, right? Either going down from here or going down from this. All right, any questions? We have 40 minutes left. All right. Let's go on to the first derivative test, and then we'll be done. Okay, the first derivative test. Okay. Guys, let's listen now and then do the stuff later. The first derivative test helps us determine which extrema are maximums and minimums. Okay, and I'll explain why that is. Helps us determine which critical numbers, I'll say. Which critical numbers are maxima and which are minima. And we can look at this graphically and it'll make sense. All right. So, a critical number can either be a maximum, it could also be a minimum, and it could also be neither. I'll show you 3 examples. Let's say we had a graph of, let's say, something like x squared, right? So it looks like that. And this has a critical number at the minimum, right? Critical number is wherever the derivative is 0 or doesn't exist. In this case, the derivative at this point is 0 because the slope is 0, right? And so that clearly shows us that we have a critical number, and this one happens to be a minimum. On the other hand, let's say we had negative x squared. Let's say we had a downward-facing parabola. This one also has a critical number at this point, right? Because the slope is horizontal there. But instead of being a minimum, this one is a maximum. I'll show you a third example. Let's say we had a graph of x cubed. The thing is, x cubed also has a critical number. It has a critical number right there because the slope is actually also 0. It's also 0 when x equals 0. And so we do have a critical number at this point, but this one is neither a minimum nor a maximum. Okay, so the question is, how can we actually look at these critical numbers and determine whether they're a minimum or a maximum or a neither? And the answer is that we would use a first derivative test. Okay. The idea is that we're trying to determine what the derivative is around this extrema, and that will help us clarify whether it's a minimum or a maximum. Here's the idea. Okay, so whenever we have a minimum, it's always going to be decreasing to the left and then increasing to the right. Make sense? So when we have this minimum here, the slope, as we're on the left side of that minimum, is always going to be decreasing, right? That's what it means to be a minimum. So it has to be decreasing on the left side and then increasing on the right side. And so if we were to calculate the derivative of this function, it would be negative on the left side and then positive on the right side. That makes sense? On the other hand, for a maximum, the derivative is always going to be positive on the left side and negative on the right side. Yeah. All right, so for the maximum, it's always going to be increasing on the left side, which means the derivative is positive, and then negative on the right side, where it's decreasing. And then where it's neither a minimum nor a maximum, you're going to have something else, something more ambiguous, such as this case, where the derivative is positive on the left side and positive on the right side. Okay, and if it satisfies that case, then you know you neither have a maximum nor a minimum. Right? It's positive, and then it briefly becomes 0 at the critical point, and then it becomes positive again. So it's not a minimum or a maximum. We know it's a critical point because the derivative is 0. Right? It's just, it doesn't cross over to become negative. It just keeps going back to being positive. All right, any questions? Very good. I'll show you guys an example, maybe similar to part B on question 3. So this will help us a lot in terms of determining whether these are minimums and maximums, and also helping us to graph without using a calculator. So let's say we had f of x equals x cubed minus 12x squared plus 5, maybe? Okay, and then the question is asking us, find the critical numbers, and then find the open intervals on which it's increasing or decreasing, and then use those intervals to determine whether the critical numbers are maximums or minimums. All right, so we'll do that. Let's first find the critical numbers of this function in this example. So we have f prime of x equals 3x squared minus 24x plus 0, right? Derivative of x squared is 2x, so that's why we got the 24. And then we're going to think about, right, where this is equal to 0, because that's what a critical number is. So where is this derivative equal to 0? Critical numbers are wherever the derivative is equal to 0, so we're going to set this equal to 0. 3x squared minus 24x equals 0. And so to find where this is 0, we're going to factor it. So we factor out of 3x. That gives us 3x times x minus 8. So this is 0 whenever x is equal to 0 or 8. So those are our two critical numbers. And then the next question is to ask which ones of those are maximums and minimums. And we have to do that by first finding the intervals where it's increasing or decreasing. And then we'll use this information to tell us whether they're maximums or minimums. Yeah, 3 steps, a lot. All right, so we're going to think about where the intervals are, where it's increasing. And so recall that the function is increasing whenever the derivative is greater than 0, right? And so that means we're looking for the values where 3x squared minus 24x is greater than 0. This is a little challenging, so let's think about it. First, let's factor it, just like we did before. So that factors as 3x times x minus 8. Okay. All right. Now the idea is we have two different numbers being multiplied together. Okay. We have a 3x being multiplied by an x minus 8. And when we have two numbers being multiplied together, they can only give us a positive product, a product greater than 0, if they're either both positive or they're both negative. So this is a little tricky. These two numbers are only both positive or both negative if x is greater than 8 or x is less than 0. So you have to do this kind of logic in your head. The product is greater than 0 only if x is greater than 8 or x is less than 0. If it's in between those two numbers, one is going to be positive and the other is going to be negative, right? Yeah. Makes sense? Like when x is a negative number, like -1 or something, 3x is negative, and x minus 8 is also negative. So they give us a positive product. Okay, and then it's going to be decreasing whenever 3x times x minus 8 is less than 0. And now we have two different numbers multiplied together to give a negative number, which means that one has to be positive and the other has to be negative. And that's only going to happen when x is greater than 0 and less than 8. All right, because if x is greater than 0, then that means 3x is positive and x minus 8 is negative. Any questions? So this allows us to write a little table, okay? And this might be helpful for you guys. We're going to write a table and indicate where it's decreasing and where it's increasing. So in this table, we're going to first have the first interval, which is -0 to 0, right? That's this one, right? When x is less than 0. When x is less than 0, the derivative is going to be positive. When x is in between 0 and 8, the derivative is negative. And then when x is, sorry, that's not an 8, is it? Thank you. And then when x is greater than 8, the derivative is once again positive. So we can write this little table. So if we visualize the graph now, we can see that it's first positive, so it's first increasing, and then it decreases for a period, and then it increases again. Okay, now we're going to think back to what the critical points were. The critical points are 0 and 8, right? And so that tells us that at our first critical point, which is here, we're going to have a maximum, right? Because if we think about what the graph looks like, it's increasing and then it's decreasing, right? And so that tells us that our point at x equals 0 must be a maximum. And then at x equals 8, we should be having a minimum, right? Because we start from decreasing and then we go to increasing. So that clearly shows us we have a minimum. All right? And so that would be our answer. We'll say x equals 0 is a maximum and x equals 8 is a minimum. And this would be a simple sketch of what the graph looks like in terms of its overall shape. And as we expect, it's a cubic function. Any questions?